Hi everyone, Assalamualaikum. In this video, we are going to discuss chain rule for partial derivatives. We now wish to find derivative of function of several variables when the variables themselves are function of additional variables. That is, we want to deal with composition of functions of several variables. This requires chain rules. The method is called the chain rule because it can be applied sequentially to as many functions as are nested inside one another. Let's say if we have u equals to u in terms of variable x, and x is given in terms of variable t. The chain rule is given by du over dt equals to du over dx times dx over dt. Okay, from here, we just imagine that we can simplify dx here. Then we get back du over dt. Okay. If we have u in terms of variable x and y, and x is given in terms of variable t, y is given in terms of variable t, the chain rule is given by du over dt equals to del u over del x times dx over dt plus del u over del y times dy over dt. Okay, we just imagine we can simplify dx here and dy here. Okay, I mean del y here. Then we get back del u dt here and then plus del u dt here. Okay, and then if we have u in terms of three variables x, y, and z, and x is given in terms of t, y in terms of t, and z in terms of t. The chain rule is given by du over dt equals to del u over del x times dx over dt plus del u over del y times dy over dt plus del u over del z times dz over dt. Okay, we just imagine we can simplify dx del d here, dx del y here, and dz del z here. So we get back del u dt and then plus del u dt plus del u dt. Then we get back du over dt, right? Alright, we only need straight d or normal d for the function of one variable. Okay, this is one variable only. Okay, so we just need straight d or normal d. Okay, we use del d for the function of more than one variable. Okay, from here we have 2 and 3 variables. So we use del symbol, right? Del d. Okay. Now we look at example 1 from previous semester papers. Find dz over dt if z equals to 3 cos x minus sin xy, x equals to 1 over t, and y equals to 4t by using the chain rule. Alright, to find dz over dt using chain rule, first step, we need to find del z over del x, okay, and del z over del y because z related with x and y, okay, and then we write in terms of t. Right, we can find del z over del x from z, okay, z equals to 3 cos x minus sin yx, okay. Del z over del x means partial derivative of z with respect to x. We treat x as a variable. So to avoid error and easy to differentiate, we can write variable x in different colors. And we can put variable x at the back. Okay. At the same time, we treat y as a constant. Alright. When we differentiate z, okay, using partial derivative with respect to x, we have del z over del x. Okay, from here we have multiplication by constant, so we just keep the constant in front here. Okay, then we differentiate cos x. Okay, because x we treat as variable. To differentiate cos x, we can refer from formula derivative of cos x with respect to x. The answer equals to negative sin x. That's why we get this. Okay? And then minus. And then to differentiate sin yx, we can refer derivative of sin single x with respect to x. The answer equals to cos x. So, when we differentiate sin yx or xy, the answer equals to cos xy. But after that, we need to differentiate yx. Okay? To differentiate yx, we just imagine we want to differentiate to x with respect to x. Because we treat y as a constant. Okay, let's say we imagine y equals to 2. So when we differentiate to x, the answer equals to 2. So that's why when we differentiate yx, because y is a constant, so when we differentiate, we get y here. Okay, we compare with this. Okay, and after that, we can simplify. So we get negative 3 sin x and then minus y cos xy. Okay. Now we find del z, but after that we need to write in terms of t. Okay, so from here, x, from here, we replace by 1 over t. Okay, and y, from here, we replace by 4t. Alright, and after that, we can simplify t. Okay, so after we simplify, we get del z over del x equals to negative 3 sin 1 over t minus 4t cos 4. Right? Right, after that, we can find del z over del y. We differentiate from z. Okay? Alright, z equals to 3 cos x minus sin xy. Okay, so when we differentiate partial derivative, okay, z with respect to y, the symbol equals to del z over del y. Okay, so del z over del y means partial derivative of z with respect to y. Now we treat y as a variable and we treat x as a constant. So since we treat y as a variable, we can write y in different colors so that we can easy to differentiate. Okay. Alright, so from here, now we treat x as a constant, means 3 cos constant equals to constant. So when we differentiate any constant, it equals to 0. That's why we get this. Okay. And then to differentiate sin xy, we can refer from this formula. When we differentiate sin x with respect to x, the answer equals to cos x. So when we differentiate sin with variable y with respect to y, the answer equals to cos xy. Okay, but after that, we need to differentiate xy. Okay, to differentiate xy, okay, x is a constant, y is a variable. So we just imagine, let's say we replace x by 3. So now we want to differentiate 3y with respect to y. So we get 3. Okay, So that's why when we differentiate xy with respect to y, so we get x here. We just compare. Okay. Alright, after that, we simplify, so we get negative x cos xy. Okay. Now we find del z over del y. Okay. So we need to write del z over del y in terms of t. Okay. So from here, we replace x equals to 1 over t. So we get this. Okay. And we replace y equals to 4t. So we get this. Okay. After that, we can simplify t. Then we get del z over del y equals to negative 1 over t cos 4. Alright. From the previous slide, we get del z over del x equals to negative 3 sine 1 over t minus 4t cos 4. And we get del z over del y equals to negative 1 over t cos 4. Right? So, after that, we can continue with step 2. Find dx over dt and dy over dt. Okay? We can find dx over dt from x. Okay? So, x equals to 1 over t. And to differentiate, we can write into the form of t to the power of negative 1 using the properties of indices. Okay, then we can differentiate x with respect to t. So we get dx over dt. X here is given in terms of one variable only. So we just use straight d here or normal d. No need to use del d. Okay. And when we differentiate t to the power of negative 1, we can use power rule. So we get negative t and then to the power of negative 1 minus 1. So we get to the power of negative 2. Or we can write equals to negative 1 over t squared. Okay. Then after we find dx over dt, we can find dy over dt. We need to find dy over dt. Okay. We can find dy over dt from y. Okay. Y equals to 4t. So when we differentiate y with respect to t, we get dy over dt equals to 4. Okay. And for y here, we only have one variable. So we just use straight d or normal d. No need to use del d. Okay. After we find dx dt and dy dt, we continue with step 3. Set up the chain rule formula. Okay. Alright, now we want to find dz over dt. So to set up chain rule formula, first numerator should be del z. Okay. We have two pairs of multiplication of derivative here because we have variable x and y. Okay. And then we have del z dt here, del z and dt here. In between must plus. Okay. And then between derivative must multiplication operation. Okay. And then we have variable x and y. So we can put dx and del x here. Okay. And dy and del y here. Okay. If above we use del z, del, so means denominator we need to use del symbol. Okay. If denominator we use d symbol, so numerator we use d symbol. Right. Looks like we can imagine we differentiate, we simplify dx and del x, and then we simplify, we just imagine we simplify dy and del y here. So we get back del z over dt plus del z over dt, then we get this dz over dt. Okay, we just imagine. Okay, this is called chain rule. Okay. And after that, dz over dt equals to, we replace del z over del x equals to negative 3 sine 1 over t minus 4t cos 4. Okay. And then we replace dx over dt equals to negative 1 over t squared or negative t to the power of negative 2. Okay. And then plus we replace del z over del y equals to negative 1 over t cos 4. And then we replace dy over dt equals to 4. Okay. After that, we can expand. Okay. Negative 1 over t squared times negative 3 sine 1 over t. And we multiply negative 1 over t squared times negative 4t cos 4. And we multiply 4 and negative 1 over t cos 4. So we get this. Okay. Negative times negative is positive. 3 over t squared sine 1 over t. And then negative times negative equals to positive. And then 4 over 4t over t squared. But when we simplify, we get 4 over t. Okay, and then cos 4. And then positive and negative, when we expand, we get negative here. And then 4 times 1 over t, we get 4 over t. And then cos 4. And then from here, we have same term. One is plus and one is minus. So we can simplify. So we get dz over dt equals to 3 over t squared sine 1 over t. So this is the final answer. Okay. Right. Coming up next, more examples for chain rule. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.